Okay. And this is my screen. I'm showing my screen and just want to check that everyone can use see this.
Yes, I can see it.
Yes, thanks. How about other student? Yes, okay. So I'm going to continue for a brief introduction of software construction. Uh, where should we start? What is software construction? How should I introduce this concept to you? Is this related to the quiz or the assignment that I asked you to do to complete yesterday, which is Svibok? What is Svibok? The the full is it Svibok is for a short word or abbreviation or just like the nickname of something? It's a jargon word for describe some things and that things. The meaning of Svibok. What is the full meaning of Svibok? Software engineering book of knowledge. Oh, sorry. Some people said book. Some people represent it as a body of knowledge. So it's been the idea of Svibok is that what should be the knowledge that every software engineering, every software engineer should have or must have. Mm. What is the meaning of must have or should have? Since you know that the word of software engineer just emerged maybe 20, about 20 or not longer than 20 years. And before that, the people know something just like programmer, just programmer do the job for the computer and the programmer will do everything and the programmer will graduate from some kind of computer science or computer engineering. So, and then by maybe you heard these things a lot, this story that the software project is not just coding to complete one software, one application. The just only coding skill is not enough. So they set up some wording, some uh not wording, some area of knowledge that must be studied in specific in order to complete the fully understanding of what should we do, what should the teams do in order to create a software. What should we do? How many knowledge should we have in order that we can manage the software project, one software project, or just any software project? That's only coding skill is enough. There are some proof that that is not enough, and they set up this kind of body of knowledge that related to the software development project. And to complete that project, the idea of software engineering, how we engineer, how we manage, how to create and complete the software project. And then they stated that, okay, what should contain in the idea of software engineering? What should be the knowledge that software engineer must understand? And the list is as a Svibok. And I think you already see that there how many of it? Tens or something. And this is a list of Sweetbox, that the body of knowledge that if you look at this one, we have one body of knowledge as a software requirement, one as a software design, one as a software construction, one as a software testing, and one as a software maintenance. So this means that on this year, since start of your third year, first semester until now, you are heading to understand. This curriculum is giving you the the explanation to understand what should be inside the software project. If sorry, if you need to manage the project, if you need to complete the software project, what kind of knowledge you must have? And for the third year student, you must understand software requirement, software design, construction, testing, and maintenance. And it is related to the Sweetbox because at the start of this curriculum, the curriculum referred and picking up this kind of topic from Sweetbox and select what should be teach in this curriculum, what should be teach in this program. So that is why you need to study requirement design and for this semester, construction, testing, and maintenance. So further than that, requirement design, construction, testing, maintenance, you see that we have some kind of configuration management, engineering process, engineering tools and method, software quality, and related discipline, which are computer science, computer engineering, management, mathematics, project management, quality management, software economic, and system engineering. This topic is this maybe more than 10 years, and something is slightly changed, especially in some kind of this body of knowledge. But you have any idea what I'm going to say?
I have no idea at all.
The thing is that you see, computer engineering, computer science is not just a one body of knowledge. In the other point of view, computer science may be larger than software engineering. Computer engineering may be larger than software engineering, right? And everything is evolved: management, mathematics, project management, quality management, software economic, system engineering. The thing is evolved the knowledge, the theoretical, the academic things always going ahead, always evolve, always develop it over and over. And yes, people need to catch up with that new kind of knowledge. Just like what should be input in here? Maybe now we should add some kind of AI, artificial intelligence. Should we put it into? I don't know. Should we put it into Sweetbox or not? But before we go further, the other thing that most of the people overlook is mathematics. Now, well, there are uh, some kind of discussion that nowadays does mathematics is important skill for the software developer is important in software project? Any comment?
Well, I think it depends, like very much so, actually.
Mm-hmm.
Like, for example, if you are like going for maybe big data or like maybe AI, yeah, I think it does matter. But for example, something like, how to say this? If it's something like drawing or just maybe animations too, like you just actually sorry, animation doesn't relate it that much, but maybe like you don't use it that much on like maybe something that does not have many calculations. Maybe it does not matter that much. But I think the logic that we have from it maybe is good enough for it.
Agree. But did you know that for animation, they heavily use mathematics skill.
Hmm.
Uh, they use it for just kind of uh, zooming in the photo. There's a mathematic inside that kind of coding
Ah,
in the 3D dimensional rotation to display the object. That use mathematics, but they use it without maybe they didn't consider that there are all that rotation or that zoom in or zoom out, all that operation that operate to the object or to any kind of graphic. They are doing it through mathematics. Why? Because all these computer things, all the digital things composed of 0 and 1. And to display anything in that, there must be some kind of calculation to display.
that's
And,
true.
and that's why for a heavily used graphic, just like for gaming, they need a lot of computational power. They need a very good GPU to help CPU rendering the object and tool. And this is what is behind that is, yes, it's a mathematic and it's sometimes it's already calculated and you're not expecting it. Even I just giving some kind of notice that some people may talk about I can forget the mathematics and I can be in the uh software business and I don't need it anymore. But actually it's an important thing that I just give you a notice, just give you an advice that uh, if you want to be a good software engineering, don't forget about mathematics. Okay. Maybe we going off for too many too long. So just get back. So I just want to emphasize that in SweetBox, there are some kind of important knowledge that you must understand, you must know before you call yourself as a software engineer. And okay, construction testing and maintenance is also some important idea that you need to understand. And that is why we study here. And maybe some other process you can study it in the higher education or the other uh, from the other point of view, just like the QA, there are some major elective class here, and some will be open soon. So in software construction, what is software construction? Many people say that to construct the software is develop the code, create a code that run corresponding to what customer want, right? And in your first and second year, you until now, you may you may work alone, or just helping some of your friends doing some kind of the projects. But if the software construction, the main point of software construction is code. It doesn't matter how good the requirement is, how good the design is. If you don't implement it, and if the code is not implemented, if it's not compiled, is that the software? No, because every piece of software is an executable file, which is run over the operating system. We develop the software, we develop the source code, we develop the executable file for use. How about web? Yes, the web is the executable file uploaded to the web server, and when the client asks or requests, the web server will process that file and send to the client, right, and display over operating system of the client. That is a basic things. So to construct the software, it's meaning that you do what? Yes, develop the code. And then what? You may think that, okay, if I can finish the code, the software is finished. But in detail, there are more than that. And if I ask you to code alone, just like in your first year in the lab of computer programming and object-oriented programming, have you ever compared your code with your friend?
Yes.
Is it different? Or everyone get the same code?
Depends on like how complicated it is. Like if it's the basics one, then mostly the same. But it changed over time. Like people has their own way of like writing their own code. So in the later years, on second year, third year, there are like maybe some distinct changes to everyone's code, I think.
It depends on where they get from Stack Overflow or something like that.
Maybe that too.
Yes, that is the point. When you try to construct a software, if you're working alone, it's fine. But normally, usually, and it's a fact that now the people, they work together as a team to develop software. And in a team is just not in one software project, it's not only one developer can complete it, right? You may have a team, requirement team, business teams, design team, developer, tester, project manager, right? This is some kind of job description that one of software project you have. And I want to point out that for one-man coding and team coding, this is different. It's very different. And when we put together the people as a team, do we have a problem? Yes. And for example, the problem that existing when you're working as a team. Yes, this is a list of the problem, and you can add it more. And it will be quiz today. Have you ever facing the problem that when you're working as a team in software development project? But this one, for this example, we have not enough detail for the next phase. But you may think the software is just one piece when we deliver it. is finished. My question is, have you ever get the finished software? Just like now, maybe you're using the Windows or the Mac operating system is standard. Every people in the world use it, right? What is the version of your current operating system? The Windows is out, just like Windows 10, Windows 11 is out for many years, and it get evolved. You need software is always update. Even on your mobile phone, there are some up. Within a month, there are a lot of updates for many applications. So the fact is that everything is keep updating, keep changing. And when you're working as a team, if you don't have enough details for what is going to be implemented for the next phase, and is it that maybe we change something, or we debugging, or we just like maintenance, create a restructure software and blah blah blah. And that is sometimes the team doesn't know what is going to happen. And sometimes it's hard to understand. Sometimes just like if you get a bad requirement, bad design, yes, that is very difficult to understand, and blah blah blah. And maybe some things, some bang things happen in Chinese New Year, and okay, I don't know whether you heard it, but okay, that's so close to me, but okay. So this is the list of problem we have. If you're working in the team with multiple nationality, we have language, description skill, pronunciation, how you talking, whether you understand it, whether you understand what you're talking about, and blah blah blah. And some kind of, if you are Thai, and if there are some when you talk about, oh sorry, when we talk about the idea, just that if you, there's something that some has to understand document idea or something, and language description skill, and the quality of the software, maybe some expect high quality, low quality, and there are many different point of view on quality of the software, and I think this will be in another course for quality assessment in the software. But the last two is inconsistency name and code design and code comprehension. This is what we are going to discuss today. This is the problem that existing when working as a team. As I ask you, how your coding style change, and how can the people understand your coding? That is the problem when we try to construct or develop the code, and when we develop code as a team. This problem always exists in most of the newly joined team. But if you have some people that working together for a long time, this problem may be reduced or not existing anymore. Anyway, why this is important in inconsistency name and code design and code comprehension? Let's see. For example, for this code, I just call some kind of object and use some kind of this. Can you see the screen? Is it clear for the coding?
Yes, can see.
Okay. This is example code that I use. And okay, you may should I zoom in? Okay, it's better now.
Yes.
Okay. This is my style. And I create object channel, I create object customer, I create object, sorry, the O2. This is the object. This is the object. This is, sorry, it's a class, and I call the class we use as an object. So it's like, if I give a name, just example. Like this. Okay. If on line number 22, I create object type O2, and I use the O2 function constructor, and I give the variable name as A. If you read my code, do you have any idea of what should be A? And then I create the other object, just like like this. Okay. If I create the variable name C as a customer type, is it okay? Yes. It's work? Yes. Can I understand it? Yes. But if I handle this code to you, can you understand what is going on for these two lines of code? Maybe or maybe not. Okay. This is some kind of, just to give you the idea that there are some kind of inconsistency in name of the variable, in also in the code design. And so that is the thing that I need to point out in when you're working, when you construct the software in, or when you in the phase of software construction, you should be carefully design, carefully implement, and sharing this thing as a team to reduce this design and comprehension problem. And for this course, we are going to talk about, now we are talk about construction. Yes, what is software development? Software construction. What is it? I think I said it once. And do you have any idea what should be the answer of what is software development? Can we call software development as a science? Yes, because firstly, we have computer science students to develop the software. Can we call software development as an art? Have you ever heard the idea of develop software as an art? Some people think that software development is an idea of the art, the art of coding. Have you ever heard that phrase? Coding is art. Some people think like that. But in the other point of view, in software development, maybe it's like a kind of process. We have input from customer, we doing the process, developing, and we have the output as a software product. How about the software development as a game, passer, gardening, farming, hunting? There are many ideas to guide you to express it as the process of the software development. But the main metaphor is that when you develop the software, is you're writing a code and make the code executable. It's like this. Okay, this code can be run. The output is here. And if I compile this Java to the executable, Java Bean is run, yes, can run. But if something like this, what happened? Yes, there's some problem in the code. And it cannot be run. So we have to accept that when we develop the software must be able to execute every line of code, every command that execute, and make the software working as we intend, working as we want. If you think about software penmanship, just people writing a code, just like we try to writing the program as writing a book, or just like writing a comic for people to understand. And it's actually maybe just from the one people activity, and we have high originality because with just one people try to develop the code, and we have originality of the idea. And this thing, preparing to throw away. What does this mean? If you develop very complicated code, very interesting and fun code, yeah, implement every knowledge of you into that software. From most of the experienced developer, they will say that preparing to throw that away because that big piece of software may be not proper to use. Because why? Because the thing is, this thing you studied last semester, develop software as a component should be better than develop software by one man as a big piece of code, and try to develop the code to be very industrious, very complicated, very ideal, or whatever it is. Okay, that is just some explanation. When you try to write the software, you try to write everything, but something is not important, and you try to put everything together and make it work. Sometimes it's not work. That is for what is like. Okay, maybe example will be shown soon. But the thing is, some of my friends, they are very. He's very genius, and he is always working alone to develop some piece of software in the project. Then what? The code is working. Yes, everything is working. Every people happy with his code, with his program, since it's working and working well. And then you may say, so what is the problem? The problem is when he left the team, when he left the company, and no one is able to effectively update his code. So preparing to throw his code away. That is the best option. Have you ever heard that in some kind of software project? Some existing project need to be updated, and the team said, okay, we will not going to update this project. We dump out, we throw the code away and reconstructing it again. And that should be more effective and faster. Just like in the lab class, and your friends ask, hey, can you help me why my code doesn't work? And you don't know what happened to his code, and you try to eat it, and you may think, okay, just delete everything and write it again, write it, and sorry, develop it again by yourself. Just delete everything and create a new code. Maybe sometimes it's faster. That is, when we're working as a team, some coding style, different experience, different. There's a lot of different in the team, different things. So that is why some kind of code, some piece of code, even it's working well, sometimes it cannot be reused, and that is the problem. This is one example for where when we develop software as a one-man show. Just like we have, and how about the other idea? We have a farming, we planting the seed, growing the crop, taking little steps to add to the system, and we don't control anything. We try to integrate everything together, growing a system. Just like develop one component and add it, develop one component and add it, develop one component and add it. Should that be better? Maybe or maybe not. But you need to understand that when you try to do this thing, everyone, the team can add it to the system, the new feature add to the system. Like we are farming. The problem is that the software can the software work? Yes. Can the software grow? Yes. But when we talk about how you control which part should be developed, maybe it's not well planned. And if you're not well planning for growing the software, like adding things to step by step, you may face a problem of what? Uncontrolling software growth. And I should say, it's not, some people try to add a thing to the system, but it's not important. It's not essential to add things. But when you're farming, you ask a team to do everything and put it together, many teams, and put it together. If they're not communicated well, you will find out that this is uncontrollable software is good, and maybe the direction of code is not what the projects want. About oyster farming or system creation, increasing size by adding, just like this is some kind of idea that we iteratively adding controlled what should we add to the software, forming from skeleton and adding piece, just like when you develop MVC, maybe you're starting from develop controller, and then you add the model, and then you integrate your controller to the web. Other than that, okay, how about mobile? You create the other method to export the API to the mobile, and then just a creation iteratively add function into the software, and that is the idea of how software should be constructed. And normally, if you need to construct a software, and the software just like this, and I think it's for example, the problem in the lab in your first year. If you have something like this, can you build it alone? Can you complete the code alone? Yes, because that this thing is designed for one-man work, and it should be complete within some period of time. Okay, but how about this one? Just like, what is different between this one, this house, and this Eiffel Tower? This is different. This is different. Yes, this is different for building this one and building this one from the common sense. This is different. Which one is more difficult to construct? Hello, anyone here?
Yes, I'm here.
How about other student?
Yeah.
Okay, my question now is from this. If I ask you to construct this student home and construct this Eiffel Tower, is it different?
Yes,
Mhm.
definitely different.
Yes, and just like this one, maybe some kind of the lab problem in your first year, and this one may be the idea of developing your senior project. So to construct the software, you must you should have the idea what are you going to do, and for a small piece of software, yes, you can develop it without any plan, but if this one for the large size project, sometimes you need a plan, you need a better preparation, you need a lot of team, because this Eiffel Tower, the idea starting in 1884, the construction took 2 years, 2 months, and 5 days, and you need 50 engineers design and produce over 5,300 blueprint, and 100 and uh, 100 iron workers produce 18,038 individual parts to be assembled, and about 121 men working in the construction site. So it's different from building the small house. Yes. Just sorry for a moment. Okay. This two slide just to give you the idea of to construct the software, you need to estimate the time to finish the workload, and that is to develop something, we need to have a good plan to complete it. So in software development, for building the software, we have architecture design, just like in the high level architecture, and we have some kind of detailed design, prepare the building site, thinking of adding the new furniture. If we're comparing this to the construction process, this is okay, maybe or maybe not. But this is some idea when we talk about when we talk about software construction. We have we hire a contractor, or we create a specific design, specific detail of a house, and prepare building site, and adding something in, or adding the new code, adding the component in. So to construct the software, what do you need? Yes, mainly construct software is coding and debugging. But it's not just coding and debugging, it's related to requirement, detail design, collective maintenance, integration, software integration, system testing, unit testing, architecture, construction planning. Everything is related to software construction. And this is just like it's pointing out that why software construction is important, because a large part of software development. What does this mean? Because coding and debugging related to every piece of software, every piece of software engineering process, related to requirement, related to the design, related to the test, related to the integration, architecture, and blah, blah, blah. And it's a main activity to judge whether the software finished or not. And construction must guarantee to be done. Otherwise, this is not, yes, the project is not finished. So when software is construction product is an accurate description of the software. So what does this mean? Sorry. It means that we need to build the software, follow the specification. What does this mean? It means that when we have a design, we have a class diagram, we have sequence diagram, we have a diagram, we have architectural design. You need to implement, follow that. Otherwise, you will not get the software following the design. And if not get the software following the design, there will be a lot of things happen. And yes, some kind of experienced developer, they will not follow this thing, and the software work. Yes, it's work, but the problem will existing will lies after the working software, when it need to be something in the software process, and that is when it needs to be updated and or maintenance, or when it's a bug or whatever it is. Because if you don't follow the design and you get the error, how can you check where the error come from? We are doing software engineering because we want to be able to trace, to check, and to control the quality of the software following the software engineering process from requirement until software delivered. And if we don't follow these things and we construct the software by the idea of why whatever one man prefer, that is not good practice. And that kind of practice, just like one man show, is like it's work, but it cannot be stand for a very long time of software. Because the software, normally software is just like, how long the Google exists? How many years? Okay.
Very
Maybe.
long time.
Yes. Is everything changed? Yes. And this is the thing that I want to point out. Everything always change. And if there's something to, and just like, oh, what should be the idea? Okay. I'll just like the motorcycle. If something, if you change the, okay, maybe sorry, the car. If you develop the car and the engine is not corresponding to the spec from the factory, you change the engine. When the car is working, you going to the service center, and you didn't provide anything idea how the engine is changed. Can the service center fix it? Maybe or maybe not. Since whenever the problem that we deliver the car to the service center, they will check the car corresponding to the factory standard first, right? And if it's not corresponding to the factory standard, they will have to find out. It will take a lot of time. Maybe they can fix it or not. That is why to construct the software, you should follow the design. You should follow the requirement, construction planning, integration plan, and the related process, not just developed by your own idea. And in detail of software construction, before you implement, from this slide to this slide, maybe it's some kind of flip of the idea. When you try to implement the things, implement the code, if you have a design document, which is the component design, and the idea is that if we have a highly complex object, highly complex design, we have some kind of complexity that is from the design people or whatever it is. For the example, this is Java code. If something happens just like this, we have this method, long running process. We have connection ID as a string, and we want to return the JSON result. If we have some kind of this kind of design, is it good or not? Yeah, maybe the question is too confused. Just like if we have this method, long running process, okay, and then we expect to write this kind of object, which is a list of string as a test list variable. And then this implemented code, this 3 line and this 1 line. Which one should be better in design as a component? My answer is this line is better because we this kind of method just calling the other method, which is this is for the repository or the model part, and it will return the test list and write it out. But if we implement something like this in our code, is it work? Yes, it's work. But what happened? when we want to change something, we need to come to this method and change. And if this method is for this kind of thing, we call it tightly bound because it's tightly implemented into this function, this method. And if we change something here, it will affect a lot of things in the other part of the software. So we need to manage the complexity, try to make the cupping. Have you ever heard of this word, cupping and cohesion?
No, no.
No? In design class, no one even mentioned this
Wait, sorry. Again,
Yeah.
cutting or
cupping.
We have then like
okay. Okay, yeah. I thought it was cupping or something. Sorry.
Cohesion?
Yes, I think so.
That's it.
I heard it as cupping.
Yes. Sorry.
Not coupling, like
Coupling.
CUPP.
Okay, sorry. My
It's
my
okay.
pronunciation. Okay. Anyway, so the idea of design, the better design is that we have a loose coupling, something like that. So when we implement, we construct a software, we need to manage this kind of problem to make it, to manage the complexity of flowing of data between or among the function or the method or the code. So we need to minimize essential complexity that any one brain has to deal with at any time. So keep accidental complexity from the needed proliferation. What does it mean? It's like try to avoid doing something like this and make its loose covering by create something like this and implement it. It's just the idea, but actually it's very important. Sorry. So to construct a class, to construct a software. Normally, traditionally, when we talk about object-oriented software development, software design, what is the base unit of the base unit of construction? Yes, it's a class. From your first year until now, when we try to develop code, we try to develop the variable or object or class. And when we design a class, we need to think about design and manage the complexity and focus on each component. Just like, what does it mean? It means that in maybe in software design, one principle for the object-oriented paradigm from the idea of object-oriented software design. When we design a class, the class must be responsible for itself. No more than that. What is the interpretation of this word? It means that the class just has one responsibility or proper responsibility. And okay, that is, if the class is the design class contain a lot of things, we should avoid that idea, and we should separate the class to make it what? To make the class has a proper functionality and responsibility. Okay, what does this mean? It means that we focus on each method of the class. If the method is not related to the class, should we put it in there? No, just like this. If the customer, should we put something just like should we put this show the product into the customer class? And something like this. Should we put this operation into this class? Is this JSON result related to the customer? If it's not, we should not put it in here. We should put it in somewhere else. Otherwise, it's like you don't have a good management for this kind of complexity. I mean that when we develop a code, we must make a code clean, effective, and simplifying the complexity of the design and simplify the complexity of the software flowing, the data flow and sequence of data calling for each function. And then this one, MVC design pattern, what is it? You already studied last semester, right? The idea is to separate the related domain into model, view, and controller. And there are some related kind of terms, just like model, view, presenter, model, view, presenter, object, just like when we develop software. The front end has its own complexity, has its own problem, has its own idea of what the software would be represent through the screen or through the other kind of interface. So we need to develop that piece of software corresponding to that objective. And then what the controller do? Controller control the logical process of the software, right? Controller will be called by the view, and controller will process. So the business process should be designed inside the controller, and that is the thing. The controller should not concern about what should be viewing or showing. That is the idea of separate complexity and implement the part of the software corresponding to its objective. And MVC is just like well-known design pattern, well-known framework, well-known architecture, because it separates three main parts of the software and implement separately and integrate it together to be one piece of working software, right? Just like the model will focus on entity, data of the system, and relationship among many business objects. Just like when you kind of query some kind of customer and customer view or whatever, it should be the idea of what should be implemented in the model, right? When the model normally will be represented as a kind of some repository object. Then when we design everything, you get some kind of what is a proper design for the class. When you design the class inside the model, or you call class or the object. Okay, first question. What is different between class and object? What is different from class and object? It's a first year question, right? Sorry. Any what help me point out what is different between class and object? Hello.
How should I say this?
You must be able to say this.
For me, object is something like how to say this? It has its own attribute, but and a class is like a classification of that set object.
Not directly.
Yes,
Okay.
like maybe something like a class is something. Object is something that is inside a class.
No.
Oh, okay.
Okay.
How to say this?
Okay.
Mm,
The line number 7. If the line number 7 is executed, we will have the object named ch. Okay. The ch will be the object.
so object is an instance of a class.
Yes.
Okay.
That is the idea.
Okay.
We create object. When the program is done, the code is done, the object is created, follow the design of the class like this. So the class, this code will be used to create the object in the line number 7. Okay, we design a class, we implement this kind of code. It's a class in Java. Okay, for we create a class, and then we instantiate that object, follow this class implementation. So we define a class for create the object in the system for using to represent some piece of data or functionality or blah, blah, blah. So what is a good class design? If the system needs to represent the customer, we need to design customer class. Okay. And if there's something that should be abstract, we should provide a constant abstraction by providing the interface instead. So focus on giving the interface without working inside the class. What does this mean? It means that in some object, okay, this is fine. Sorry. What is the difference between abstract class and interface?
So again, please.
Abstract class and interface, how they are different. It's the first equation. Okay.
I see it. Why is there no one saying anything?
The thing is that I don't know what is your background in Java programming language, but the thing is that abstract class is a type interface is a type. If you understand the word type, object, what is type of this object? Is a type channel.
Channel.
What is the type of this C1 variable? The type
Customer.
Yes. When we define a class, when we define abstract class, when we define interface, we define a type.
Oh, so abstract class is a place that we define an abstract type. Then in interface is something that we implement that said class.
Or we can implement abstract interface in abstract class or not. It depends on design. But
Okay.
it's a equal thing. This is will be a type of observer for this example code, and this will be the type of abstraction type. Okay, two of these are different type.
Okay.
But maybe that is things for the first year, second year, and third year, first semester knowledge. I think maybe you come back and review that. But what I want to point out here is that for good design of the class and object, we need to provide consistent abstraction. What does it mean? It means that you see that this example code, we have one abstract class and just one abstract method update. And this is no implementation. What does this mean? It means that for this example, observer type, observer one extend or implement from the observer abstract class, and it's implement its own update method. So when we call the observer update method, if you execute this code, and then what? Then if you want to have the different update method from the from the observer one, we can have another observer that implement the different update method without changing any kind of code here. Okay. This is the code for design pattern for the observer pattern as an example, but I just changed the code detail. Maybe it's too abstract or it's too complicated. But anyway, the idea is that we implement something here. And if not, we can override it, or we can provide just interface for the idea of implementation and give the flexibility of the detail implemented to the other people. And that is the idea of good design. We should have some kind of abstraction. We don't need to implement everything into the class. That is the basic idea. And encapsulate the implementation detail, high detail inside the class, allow the other to call the class via the interface. Or some in this slide, we said via the support. It means that we will provide a method description and the method argument as a support document for the other class, for the other part of the system to be able to call it effectively. And we need to hide complexity. Complexity is like, for example, the part that we think is hard to understand in implementation and unexpected part. The best example will be this code. If we hide this, we don't need to implement anything. Just comment it out. Anyway, just like if I comment this out. You see that we just call repository to get the product list. And the people and this code and the people just call this code and then we get the product list without anything. Without I said that they can just get the product list from the repository. The repository will do its work, and you don't need to implement the repository class. Just call it and use it. And the complexity is hidden inside the get data from database method from this repository, and that is it. And this is the idea of good class design. And and this is and the idea is that encapsulate implementation detail, hide it, separate this complexity out from the method if it's not needed to implement it there. And what else? What should be a good class design? We should properly use the inheritance. We should sharing some attribute or method through the inheritance. But we should concern about what should be the proper depth of inheritance. If we have a high depth of inheritance, what is going to happen? What is going to happen if we have high depth of inheritance? Come on, it's question from last semester. Okay, doesn't matter. For good class design, you better use the inherit for the thing that's already existing, and you want to add some more functionality or change the responsibility of the class. It's good to use inheritance, but just when you use inheritance, just be careful not to overuse it. And the good class design just encapsulate everything, hiding the unrelated information, just show what is need to show. We hide secret attribute, we hide internal routine, we hide, and the interface should review as little as possible. Just to the idea is that you don't need to export every function, every method to outside. You just need to provide what the function that the outside going to call, but in the inside you should hiding the implementation detail. And when we do some kind of information hiding through the encapsulation, we need to create a barrier for information hiding to control the excessive distribution of information, to control the circular dependency, and to avoid the class data for global data. We should not do that. And if we do that, we have a class data for global data, we will have the performance issue, because if we have a class that will be called from anywhere, yes, it affect the performance things. Okay. Any question now? If not, I'm going to continue until we finish the presentation. And do you want to take a break? Hello? Should we take a break or no? We have 4 students. Okay, I'm going to continue to finish this presentation, and then in this afternoon I will assign some quiz, and I will give you the schedule for next week. The thing is that this is explain it all of this, that we will explain what is a good class design. It's based on idea of object-oriented programming. And when we design something, if we find the area that's the area that's likely to be changed, what it is, it's like when we talk about requirement and design, some part of the code that needs to really implement or is fragile to change So we need to identify that the area or the part of the code that likely to be changed, and we identify this by checking sorry, by checking whether just like does the database need to be changed from the just like from MySQL to some kind of non-relational or something like that. You need to identify part of the code that if you have something that likely to be changed, you should isolate that unstable area out and identify it, maybe find from the requirement that something is likely to be changed and separate that item and provide the interface instead. You should separate that item that's likely to be changed and provide abstraction there and implement it. So just like if we have a class A, we have a list of product which is written from the database. And if this one is changed from this one to the other database, what should we do? Do we need to implement everything inside this method, or we provide repository and just switch the repository in this line of code? Just one press and everything is fine. That is the idea. Separating the complexity, identify the area that will be changed and put the abstraction there and implement it somewhere else. So something if something changed, we can change the implementation and plug it back to this line of code. And this is a guideline that you need to be carefully identifying the area that normally change in the software. First is business rule. Second is hardware. Third is input and output, just like, okay, has a simple explanation for output, just like web output or mobile output. The inputs may be some kind of command line interface or graphic user interface. That is an example idea of what is likely to be changed. And some kind of non-standard language feature, just like input for Japanese language, Chinese language, or English language, or Thai. It can easily change because there's multiple people using the software, multiple multinationality people using the software. Like even yourself, sometimes you're using some kind of application, you always switch from Thai to English or Chinese to English or something like that. This is the area that likely to be changed. So just to be careful to carefully provide abstraction for this area of software project. And this caused the difficulty in design and construction because it changed and it's always happened. And inside the code, the status variable, they're always likely to be changed, just like maybe 0 and true or false. I recommend not to use the true or false, just give it more enumerated type, maybe 1, 2, 3, 4, 5, because that if you use true or false, sometimes you have the third or fourth state that you have to change everything in your code. And we should better use get and set than calling the variable directly, because some people may change it without any notification, and that is cause some kind of error in the software. And the area, the other part of things that change is that the array size. Because if you in the first year programming, if the array size is fixed, you cannot change. And if you try to iterate this, the size of object over. Okay, that's right. If you have array of 10 object, if you access the 11, if you access the 11 point, sorry, the 11th array, what happened? The error. So, and a lot of inexperienced developer, they try to use array, and if they don't check the length and the size of the array when the code is done, sometimes it's working, but sometimes it's not working, and it causes a lot of error inside the software. And yes, keep the coupling loose. And I think we already discussed it. We should provide this kind of loose coupling instead of the tight coupling object. And this is a coupling criteria. Okay, I think I should stop here. Okay, I will stop at this slide. And I will assign you some quiz, because I think I'm going too fast now. Okay, I will stop at slide number 34, and I will continue. And I will check for the available schedule and provide next week's schedule for you within tomorrow. And I expect more students to join the class. I want more interactive, so we can discuss whether you understand what I'm talking about or not. And okay, anyway, thanks for joining the class. I will stop here and I will rearrange the schedule. And okay, see you next week. I prefer Monday morning, and I will let you know. Okay. Thanks for the class, and I will upload this presentation so you can come back and check this one. Have a good weekend, and bye.